For over a century, the world has run on a fragile promise. A promise sealed in liquid, a promise that leaks, degrades, overheats, explodes, and dies. Lithium-ion batteries powered the digital revolution, but they were never meant to carry the future. And now, for the first time in human history, that promise has been replaced. This is not a prototype. This is not a lab experiment. This is not a press release inflated by marketing jargon. This is mass production. The world's first commercial-scale all-solid-state battery capable of charging in 5 minutes, surviving up to 100,000 cycles, and operating without flammable liquid electrolytes is no longer theoretical. It exists, it's being manufactured, and it will redefine energy, transportation, and technology itself. Act 1. The problem we pretended was solved for years. We were told lithium-ion batteries were good enough. Good enough for smartphones, good enough for electric cars, good enough for renewable energy storage. But behind the scenes, engineers knew the truth. Lithium-ion batteries are fundamentally limited. They rely on liquid electrolytes that burn chemical reactions that degrade internal structures that fracture over time. Every charge cycle slowly kills them after 1,000 cycles. Capacity loss after 3,000, performance collapse after 5,000, performance collapse after 5,000, disposal. Now imagine a world trying to electrify everything: cars, planes, ships, factories, cities, using a technology that degrades by design. That's not a transition, that's a bottleneck. And engineers have known the solution for decades. A battery without liquid, a battery without fire, a battery without decay, a solid-state battery. But knowing the solution and building it at scale are two very different things. Act 2. Why solid-state batteries were impossible. The idea of a solid-state battery isn't new. In theory, replacing liquid electrolytes with solid materials solves nearly everything. No leakage, no thermal runaway, higher energy density, faster ion movement, longer lifespan. So why didn't we already have them? Because reality is brutal. Solid electrolytes crack. They resist ion flow. They form dendrites that short-circuit cells. They require atomic-level precision. In a lab you can make one cell work. In a factory you need millions of identical cells, each flawless. For years, every attempt failed at scale. Ceramic electrolytes shattered, polymer electrolytes degraded, sulfide materials reacted with air interfaces collapsed under pressure. Solid-state batteries became the industry's favorite lie. 5 years away. Always 5 years. Never arriving. Until now. Act 3. The breakthrough no one thought would scale. The breakthrough wasn't a single invention, it was a convergence. Material science, manufacturing automation, AI-controlled quality systems, nanostructured interfaces. Instead of forcing old factory methods to work, engineers redesigned the entire production philosophy. The key innovations: 1. A stable solid electrolyte, not brittle ceramics. Not unstable sulfides, but a hybrid solid electrolyte engineered at the molecular level, flexible enough to absorb stress, dense enough to block dendrites, conductive enough to move lithium ions faster than liquid ever could. 2. Interface engineering. The real killer of solid-state batteries was contact resistance. Now solved using nano-textured electrode surfaces, self-healing, interlayers, pressure-balanced stack designs. The battery doesn't fight itself anymore. 3. Dry manufacturing. No toxic solvents, no moisture-sensitive environments, no expensive vacuum chambers. This alone slashes production cost and complexity. For AI-controlled quality control, every cell is scanned, modeled, and stress-tested digitally before leaving the line. Defects aren't discovered later. They're prevented in real time. This is why mass production finally became possible. Act 4. The numbers that sound fake but aren't. Let's talk about the claims, because this is where skepticism is healthy. 5-minute charging, not marketing magic. Solid-state electrolytes allow extremely high current density without heat buildup. No liquid means no boiling, no gas formation, no thermal runaway. The bottleneck shifts from chemistry to infrastructure. With proper charges, 5 minutes is not a stretch, it's conservative. 100,000 charge cycles. This is the real shock. Most lithium-ion batteries fail due to, say, layer growth, electrolyte breakdown, mechanical stress. Solid-state cells eliminate or stabilize all three. At 1 charge per day, 100,000 cycles equals over 270 years, even at extreme usage. The battery outlives the device, the vehicle, and likely the owner. Energy density higher than lithium-ion, lower than pure lithium metal. Theoretical limits, but usable, safe, and stable. This isn't about chasing numbers, it's about real-world performance. Act 5. Why this isn't just an EV story. Electric vehicles get the headlines, but they are only the beginning. Grid storage. Renewables suffer from intermittency. Solid-state batteries last decades, require minimal maintenance, pose no fire risk, can be installed inside cities. This changes energy infrastructure planning completely. Aviation, weight, safety, reliability. Solid-state batteries make electric regional aircraft, hybrid long-haul systems emergency safe. Power systems finally viable. Consumer electronics. Phones that charge in minutes last weeks never degrade noticeably. Laptops that outlive their keyboards. Wearables that never fear overheating. Industrial and military. Extreme temperatures, high vibration, zero tolerance for failure. Solid-state batteries thrive where lithium-ion dies. Act 6. Why mass production is the real revolution. A prototype impresses scientists. A factory changes the world. Mass production means cost curves collapse, supply chains adapt, standards form, adoption accelerates. Once a technology reaches manufacturing scale, it becomes inevitable. This is not a future prediction. This is a point of no return, just like the transistor, the lithium-ion battery itself, the internal combustion engine before that energy storage has crossed its next threshold. Act 7. The economic shockwaves. Entire industries will feel this.